Hey folks, welcome to the stream. Sorry it's later than normal. Excuse me. Um, I was out in the cold today, watching a soccer game in person, and unfortunately my home team lost. But it was a pretty intense experience. But so we're just gonna do a chill stream. Probably gonna work through a tutorial or something. And this is new content, right? We're doing we're looking at doing the game jam, um, and uh, the theme will be revealed pretty soon, and then the game jam starts toward the end of the month. So we have some time to get familiar with what's available, and the one of the people who is helping run the game jam started a framework called Tiramisu. So if you're here on the stream, welcome. Let's figure out how to use Tiramisu and see what we can build. So this is going to be a completely new thing, and should be fun, I hope. It's good to take a break from the compiler stuff as much as I've been enjoying it. There are things about it that I realize are not the most enthralling content. I think it's really informative to me. It really opens up a lot of understanding of what goes into building a compiler and design decisions in your language. And just like, a little peek at the research that has gone on. But we're gonna do Gleam game stuff today. So let us see what we got. This is what I'd like to prepare for. You can, well, it works on mobile. You can like tap here and Lucy will move around. But there's some rules here. It's gonna start on November 21st. Sorry, that's really small. And it's gonna last 9 days. So what I'm hoping I'll be able to do is do 2 streams where we just work on the game jam, and maybe if there's, since that's going to be spanning the Thanksgiving holiday in the US, maybe there's an opportunity for me on, say, the Friday and Saturday of that week to stream as well. So we'll see. I don't know what the theme is going to be. That'll be really interesting to find out. But this is what we're shooting for. We'd like to do something. And of course, this is pretty typical of game jams. The criteria the games will be evaluated on is theme, interpretation, innovation, and polish. So there's opportunity to use some frameworks. So we've already done some Luster. I've been poking at it on a separate side project that I haven't published anything on, but Luster will be really familiar. Tiramisu is the thing we're going to look at today. It looks like there's, let's look at Paint, what this is. It looks like it's just an app. Oh, okay, so you can draw things using what looks sort of like SVG type stuff. That's pretty interesting. Okay. So, interesting. Okay, well, let's flip over. I already have the Tiramisu docs pulled up here. So I'm going to make a new window in Z, and we'll get, it doesn't let me open a shell, so we'll use iTerm for now. And, oops. Okay, and you all can't see that, so There, that's a little bit better. I think I still have the weird terminal font on this. All right, well, let's go to the getting started guide. Okay, so we'll do this. And I'm just going to call this Tiramisu demo. We'll just do that. Okay. And let's just Z. Oops, I need to put a space in there. Okay. Okay, so we've got Tiramisu demo up here. And let's do bottom half, bottom center. So I'm looking at my window manager thingy. Yeah, that's right. What we could do is we could do fourths and make this the third fourth and make this the second fourth. And I should have keybinds for that. That would be nice. Okay. So they say the easiest way to start is using mascarpone. Ha ha ha. I'm sure the puns with this library will go deep. I appreciate the effort, the enthusiasm in bringing puns to more libraries. Okay, so we're going to do gleam add -- dev mascarpone. Okay, so this is sort of like the Lustre dev tools that we used in our Lustre part of the compiler app. Okay, and this is going to help us get set up. So Gleam run. Excuse me, I've had quite a day. I'm just going to keep it chill. Okay, so Wizard will help you set up Tiramisu for your game project. Okay, cool. Hit enter to continue. Include get Lustre. Yes. Okay, so so we could pick a template. I think we'll do 3D. We've done 2D stuff in the past with Betty. Excuse me. Halloween candy. Let's do 3D. And I would love to have physics, but maybe we can add that later. Okay. So do we want to create a desktop bundle? I think for right now, no. We're just going to run it in the browser. And that's fine. So a little bit about Tiramisu. Let's quickly flip back to the main page. It is built on top of 3.js. So whatever 3.js can do, basically Tiramisu can do if there's the correct binding. And most of the stuff is bound. That means if 3.js works on, say, like Node or Bun or Dino or any of those JavaScript runtimes, then our stuff will work for that, because leveraging Gleam's compiler to JavaScript in the FFI, it basically just writes JavaScript. It doesn't do anything wonky. It doesn't use WebAssembly. So you can run it natively inside a native runtime, or you can run it in the browser. Okay, I shouldn't say natively. I should say a desktop runtime versus a browser runtime. But we're going to use the browser. So let's not bundle for desktop. Okay. Okay, so it got everything. Okay, Control X. Cool. So now we can let's have a look at what it put in here. Okay, so it threw some boilerplate in here, which I'm guessing is this. Similar. And we'll have a look at all the pieces of this. The style of programming here is, again, it's similar to Lustre. So you'll have a model which will define for each game and possibly each subsystem of the game, and then your main function will do call the framework run and pass it the init, update, and view functions. And then dimensions, I think we'll look at some of these things as we go. Note here they have some dimensions set. We might want to do full screen potentially. We'll see. And then in the init functions, those take a context, which I'm guessing okay, so it has some stuff in there that we'll make use of. And then similar to Lustre, you return the model from your init, any effects that you want to create. And I don't know what this option is for, but we'll learn about it. I think that this either is out of date or it's using a slightly different signature than the example here in the docs, but that's okay, we'll figure it out. Okay, and then the update is like, what messages did you receive? So these would be like tick is the game loop. So this is like your, in your browser, this would be a request animation frame callback, would produce tick. And then if you have any other messages like dealing with input or dealing with things that you want to schedule for the next frame, any side effects that you need to perform, loading assets, for instance, that all could happen here in update. I want to say loading assets, like the result of loading assets, not triggering that because that's a side effect. Async, etc. Okay, and then the view is like take the model and give me a scene. So it feels a lot like the model view update pattern from Lustre, which is the same as in Elm. And that I think they will make it really nice to define the contents of our game. It's a little bit more monolithic than this sort of piecemeal systems with like explicit scheduling and magic type signatures and such that Bevy does. This is very much more straightforward, but you have to think about this is like the render graph part. This is the world updates, and I'm guessing that I'm seeing IDs on things here, so I'm guessing this is how it does its diff to know what to change. So we're gonna have to be very careful about putting IDs on our stuff. Okay, so this is what it generated. Let's just run that. Okay. Let's see what we got. Okay, so we got a ball. Looks like we've got some. Oh, we're just going to need to potentially see if there's anything out of date there. So we've got a ground, which is just a quad mesh. We've got a sphere, and and we've got a directional light. And there's an ambient light. Okay. So that's pretty cool. Let's flip back to Tiramisu. Okay, so it follows the MVU pattern, the Elm architecture, init, create the initial game state and effects. View, render the current state as a scene. So all of these things, with the exception of the update we want to be careful about, but the view could be, we might start to make components which are things that like take a sub portion of the model state and produce a scene node, right? Be it a camera or a light, or some kind of mesh. Okay, so again, the model's a mutable game state. In order to affect a change on the screen, we have to change the model, right? Or at least how the model maps into the contents of our scene. Okay. This is nice. The camera API looks very, very straightforward. Okay, and here they're defining the aspect of the camera, the field of view. So the perspective, near being like very small, and far being bigger. So Z is going into the screen. I'm guessing that means X and Y. And that's interesting. So this is left-handed. So notice what I did there. If you think of X going horizontally, Y going vertically in the view, and Z going backward and forward, which is pretty typical. So here near, Z is small. So if we're, the way that you know whether something is right-handed or left-handed coordinate system is if you start with your, say start with the X, and this is gonna be backwards to you all. But if your fingers are pointing in the direction of the X and you curl them toward the Y, then your thumb points at the direction of Z, positive Z. So fingers on positive X, curl toward the positive Y, your thumb is at positive Z. Now the problem is Z is positive going into the camera, or like into the distance. So that means that this is not right-handed. Right-handed would be Z would be greater toward the viewer, but it's actually away from the viewer. So that means your left hand, if you started your left hand with X is on positive, curl toward Y, then the thumb points positive Z. So we know this is a left-handed coordinate system. That was a very long-winded way to talk to you about the cross product. Okay, so I'm going to let's make this full. I don't know what's going on here. This received invalid request. I think there's something wrong with our example, but that's okay. Okay, so it's just saying the model is unused. Yeah, we're not making use of this, but maybe we can play with this a little bit. So one thing that's interesting here is on this update, the context is going to have some stuff in it. We should go look at that. So let's look at the docs for that. Okay, so context type, and hey, I was just thinking about that. We need to learn. Okay, so timing input and canvas dimension information. So this is current canvas width in pixels and height in pixels. We could do some adaptation of the camera perspective potentially if we get certain dimensions. Okay, so delta time for movement and animations to ensure frame rate independence. Okay, for example, if you want an object to move 5 units per second, multiply 5 times context delta time. Each frame. Effects are side effects that may return messages. So this effect.tick is the thing that we kick off. So request the next animation frame and dispatch a message. And what are we passing here? We're passing a variant of our message type. This is what you'll send on tick. So they've basically done, yeah, and every time we process a tick, we return an effect which triggers the next request animation frame. So this is basically the same thing you'd do if you're manually doing a render loop in JavaScript. I don't know what this plus dot is. I have never seen that. Did I just mess that up? No, it has to be plus dot. I guess the plus dot is float. Okay. Okay, so what we can do, let's do a little, let's think about moving something on a timer. Okay, but first let's get through this. We're almost done. So effects are things like tick, or you can make custom effects, or you can batch multiple effects together. And we'll make use of those sorts of things to like handle any sort of interactions that we have with the user, I think. Okay, view function returns a list of scene.node ID. Right, okay, so we'll use the scene module a lot. Okay, every scene node has a transform, position, rotation, scale. The transform type is opaque, so use the builder functions. Okay, rotation uses Euler angles in radians. So we're not using quaternions, I guess. At least with these rotations. There might be some like with quaternion rotation. Okay, so I think what we should do is let's scale that sphere up and down. I think that's a good way to go. So we're going to say let sphere scale. And we're going to make use of the time part of the model. Okay, so let's do sine. We're going to have to look into another Gleam. Oh, I should just use my quick link here. Okay. Does Gleam have a sine function in float? No. Okay, it's not in standard lib. Let's see if Tiramisu has any of those functions. Let's see, maybe it's in geometry. And I'm going to have to make this bigger so it can get the sidebar. No. Okay. Transform. Okay, those are interesting. Yeah, I need the sine function, or cosine doesn't actually matter to me. Let me just have a quick look. I mean, I could bind to something that's in. Yeah, oh, Gleam Community Mass. Thank you for the call out. Let's do that. And we'll comment this out to begin with. Okay. Gleam add community maths, I think. Okay. Let's import Gleam community maths. Okay, it's just going to import as maths, I'm guessing. Okay. Thank you for the shout out. That was very helpful. I'd forgotten that that was there. So maths dot sine. So let's do sine, and we're going to use this should take a float. Yep. So we're going to use the time in the model. Okay, and then we're going to let's multiply that by 2. So we want to grow by a factor of 2. And we're going to say it's going to be a minimum of 0.5. So it's going to get quite a bit bigger than the original, and then shrink down to half at minimum. Times 2. And these need star dot plus dot. It's one thing I'm not going to remember. Okay, so we've got the camera, we've got our lights. We can improve the lighting, I think. But let's do transform at this, transform with scale. And this is going to take a vec3, I'm guessing. Yeah. Vec3 dot splat. There we go. Love it. Sphere scale. Okay. So this will. I think the problem we might want to. So for every second, I'm guessing that's what time is. It's just a float. I'm guessing that's well, let's just run it and find out. Because we've got we don't know what it's going to be yet. Okay, so that's way too fast, right? So we need to I'm guessing this is in milliseconds. So let's start by dividing by 1,000. Well, it helps if I put a dot in there. Okay, that's much better. Yeah. So transform Euler to quaternion if you want quaternions. Yeah, I saw that. I'm not ready to do rotations yet. I just wanted to do a simple, like, let's look at the model. And now you note here that there's some issues with, note it doesn't go all the way up. We're not getting an even sine wave there. It should go up to 2.5 and go down to 0.5 for scale, but it's kind of not consistent there. So I think that what we might want to do is, rather than model time, maybe what we do is we do context.delta. No. What that? We'll have to think about that. This is the easy way because every time we tick, we're updating the new time. Look at that little specular highlight from that directional light. Overall, the whole thing's dark, though. I'm not real happy with that. It could also be our maths being wrong here. Note that it's going down to 0 as well. I think that actually what we want is +1. Or maybe even 1.5. And then it'll only go down, or it should only go down to 0.5. Yeah, this is really here. Refresh. Anyway, okay, so we've done something basic with the scale there. That was fun. This intensity is interesting. Okay. Right, so higher for harsh sunlight, lower for overcast. Okay, so let's bump this up and see what we get in terms of the. Yeah, that's quite a bit brighter. Is the flicker in the back probably from the video encoding? And my apologies for that. I have this downscaled when I stream, so my full screen dimensions are substantially larger than what you're seeing on stream. Partly why I bump up the text size so you can see what's going on. Okay, let me flip back to having this side by side. That'll be way more useful. And I can hide this because we're just going to play with this. So that we changed the light intensity to 1.25. Let's see 1.5. Okay, so notice how it's quite a bit brighter. That spot gets really intense. Oh, good. Could just be a stream lag. Okay, but if we put it to 1.25, and unfortunately there's a hard refresh there, it gets a bit softer. Okay. So I can see why they did 0.8 because like that makes kind of harsh highlights. We could bump up this to make the ambient light brighter. Okay, so I don't know if you go, so 1 would be pretty bright. Yep. I don't know if you go over 1, what you get. A bit washed out. Okay. All right. Okay, so we've got the basic stuff going on. We did a little bit with this. I think that the more appropriate way to do this would be if our thing is going to oscillate the scale of this sphere, we should be doing it in the model update and then be keeping track of it there. They have some things about frame rate independence. I'm guessing that this like inconsistency of notice how it was small and then like we should be getting a straight sine wave there. This is an angle in radians as well. So it could be the issue of not only did we just scale it, but we just skipped past things. So if we wanted potentially, if this delta time, okay, so this is milliseconds. So so we're adding to this. If we want it once per second, okay, but this is in 1 second going from 0 to 1 radian, right? But maybe we want every 2 seconds and we can just actually leave the 1000. Let's multiply by maths.pi, right? So that would be like in 1 second we'll do 1/2 of the period of the sine function. We're still not getting it even. Okay, so let's do that in 2 seconds. I wonder if there's something wrong with this sine function. Or if it's just this, we're doing it in the view and we should do it in the model. Well, let's tweak things. Let's update our model. So let's say this is sphere scale, and that's going to be a float. So the other thing is, let's switch to using cosine when we do this, because we want it to start at 1. Okay. And I'm going to cheat. So let's say sphere scale is going to be time mass dot cosine of time times maths.pi divided by 1000. And then what were we doing before? Times 2. Let's leave the times 2 off. And let's add 1.0. Okay. And we're going to get rid of that. And we're just going to do times sphere scale. Save ourselves some stuff. Okay, and here I'm just going to say model.sphereScale. So it's only going to call into this with something that we computed on the tick, not on whenever it manages to render. I don't know if that's going to make it better, but okay, let me think about this. So actually we do want to use sine, right? Because if we're starting at 1, sine goes up, so it's going to go up to 2, then come back down to 1, go down to 0, come back up to 1. And that's fine. I think I was thinking cosine because cosine starts at 1 and then goes down. It doesn't actually matter that much. Okay. You know, this looks a lot more consistent. I don't know if you can tell. But we're not getting the oscillation be like somewhat randomly within the like the amplitude is consistent. That's what I mean to say. Cool. Okay, description of Tiramisu says excellent support for 2D, but it does appear very 3D focused. Is that your honest impression? I don't know. I think it's just that you need more stuff for 3D. And so there's more code there. Same thing happens with Bevy. You need more stuff for 3D. So for example, in Bevy 3D, you can have physically based rendering, which simulates lighting very well. Lighting and when I say texture, I mean like the things like roughness and like the physical attributes of of a material. It does that very well. But yeah, you just need more stuff for 3D. I don't know if there is a. Let's see, I was poking at physics here for a second. The scene. The thing is, it's and I'm sorry I messed that up. There we go. Okay, there's not. This is all built on top of 3.js, right? So, um, we could achieve some 2D like effects in 3D, which is usually how you do things, because graphics APIs and cards and such are designed to support 3D. And you like emulate. You can often emulate 2D things in 3D. But here, just like it's mostly camera perspective things. You create an orthographic camera instead of a a perspective camera. Okay, so we can do. Oh, this is good. So groups we could do potentially, if I'm understanding that correctly. We'll read this, but you could do nested transforms, which would be super useful. And I'm guessing this is the basis on which you could import things like GLTF, which we'll probably want to do. Okay, so meshes are 3D objects. Okay. Oh, note here, there's like, we could play with materials in here. Okay, so they got some materials, but they're not adding anything to it. It's just saying this has this color. And these metal and roughness things are part of a PBR style. So metalness would be like how much it reflects light, and roughness would be how much it scatters light. So yeah, interesting. Okay, geometry types. So we've got boxes, spheres, cylinders, planes. I think we have a plane in here. Yeah, it's a ground geometry. Let's see. Yep, geometry plane. Okay. And circles, cones, torus. I'm assuming, again, this all probably comes from 3.js and it's just a shim on top. Okay. All materials are created using the material module and return a result or material error. The standard material is PBR. Okay, so with metalness, roughness, and they're recommending that. I guess if you want to apply a texture map to paint it, a normal map, which would give you deviations or from the general geometry, or create things that look like they are uneven surfaces. You could use the normal map for that, and it'll scatter light in different directions. Okay. So I don't know if all of you'll follow Chris Biscardi's streams on Bevy stuff, but he's done a lot of things with materials and playing with roughness and so forth. And it looks and normal maps and such. And I don't know like if we could do baked lighting, but that's quite a bit later. I just want to get something going. Ambient occlusion map. That's interesting. We have a lot to learn there. Okay, so material new. Yeah, that's a PBR material. So if we wanted to do basic, this is unlit flat color. Okay. Probably wouldn't use that. Fong material would be the thing that gives you the very simple thing that gives you specular highlights that kind of simulate reflection, if I recall. Lambert materials are matte, so they reflect diffuse light only. So be something you don't want to have any reflective. And then cell shaded. Cell shaded might be fun. Which I'm guessing that has like high diffuse. When I think toon materials or cell shaded, I think of things like any of the recent Zelda games, like Breath of the Wild. Wind Waker was toon shaded. Of course, Tears of the Kingdom, but the effect there is that you have some shading based on light, but it is blended across each polygon, so you get a very kind of looks like hand painted look to it, and flat while being 3D at the same time. Which is different than this basic material, which is like it's always the same color from any direction, whereas a toon material I would guess would still interact with lights. Okay, what do we got in lights? We got ambient lights, so that's uniform in all directions. You just use that to raise the brightness of the scene. Directional light. Okay, so this is parallel rays like the sun. So if you have a very distant directional light, we could simulate a sun being in a particular position. Okay, so you could place it at a particular spot. And then a point light would be something like you would put in the scene, like a lamp that radiates in all directions, but would be would have a specific position. And a spotlight would be similar, but it would be like focused, like volumetric or something. Okay, hemisphere light, that's interesting. So we could make a sky and ground color. Oh, that's what you mean by hemisphere. There's a sphere, but it's only half of it, and the lit part down here is a different color. Okay, cameras. So the perspective camera. So here's what you're asking about 2D. Here's an orthographic camera, which is you would set the dimensions of your view space. If you wanted to treat it, the center is 0, 0, and you go from -10 to +10, and so forth. Then you can do a 2D cam. Okay, so here's just camera 2D. That makes it easier. And note that this, Z is positive toward the camera. No. That's interesting. Okay. Ooh, multiple cameras, picture in picture. Okay. That could be fun to do. The question is, like, how do you create those separate spaces so that your mini map camera is looking at specific things? Let's see. Oh, okay, so they said it's up above looking down. That's what the mini map camera is. Interesting. And you can set the viewport on it. So the viewport none would be full screen, or the full width of the canvas. And this viewport would be like, pick a corner for that camera. Very cool. Active, false. Okay, group nodes contain children, creating parent-child relationships. Okay, so we could create a group with a player transform, and I'm guessing, yeah, so these transforms inside here are relative to the parent. This is probably easier to understand than Bevy's transform and global transform. Here you can think of it as a strict hierarchy, and if you group these things together correctly, they will get transformed together. Yeah, so we could build up some complex objects with groups. just do some regular functional decomposition. Probably a typical thing we might need to pass in here is have an ID or an ID prefix. And I don't, we are doing this. This scene node is parametric over string, but I guess there's nothing that says you couldn't use some other form of ID for the node. That's interesting. Okay. Every node has a transform. Right, so use builder functions. We saw that. Comma rotations. Okay, so we might have to do some maths there. Instance rendering. This is really interesting. Do lots of identical objects efficiently. Right, so you give it the geometry. This is the same geometry, same material for all of them, and you just give a bunch of transforms. Pretty typical thing to do with an instance mesh. That's impressive. I mean, that's all 3.js, but if you know what you're doing, you can make those things really efficient. Okay, level of detail, automatically switch detail based on distance. Oh, right, so you could build something that has a really complex geometry with lots of detail up close, and then something that's much lower poly at a distance, so you're doing less work in the render. Okay. Okay, let's read about what it does with scene diffing. So Tiramisu automatically detects changes between frames. What triggers updates? Node removed. Okay. Node added. Transform changed. Material changed. Geometry changed. If a node is identical between frames, no patch is generated. Use meaningful IDs. Okay, so the basic example uses strings, but I think that this is really good idea. We'll make our own type that's going to be more efficient to compare than a string. Okay, so you're saying keep hierarchy shallow. This could be a challenge if we're using some imported asset. I actually was thinking I might want to pull in some Kenny assets to see if we can load those and do something funky with them. Use instance mesh for repeated objects, of course. Okay. Minimize material geometry variety. Debug visualization. We could put some debug stuff in there. Let's do that for fun. Sorry, this is the first thing I've actually wanted to try. So let's throw in there debug.axes ID world origin vec3 splat 0, and we want size. Let's do 20 because I think that axes. Okay, well, we're not gonna. It doesn't like the labeled arguments for some reason. Whoops. Got some window confusion there. Okay, so we've got our axes there. And what does it say on x equals red, y is green, z is blue? So red to the right, green up, blue toward the screen. So it is right-handed. That is interesting. I thought that it was going to be left-handed. Well, let's shift the camera around a little bit. Okay, so look at that. Okay, so this is 5 up and 10 out. Yeah, okay. So let's go over to the left a little bit, -2. And now you can see, z positive going this way. Interesting. Let's see about handling some events, because like I would love to be able to say drag across the screen or even move the mouse across this and get the rotation of the camera to change. When I say the rotation, I mean like its position around a circle. That would be a useful thing to learn how to do. Okay. So we need to find something about input events. Input. Okay, so yeah, let's do that. Put this on multiple lines because I'm going to need to. Let's get Tiramisu input in here. Not animation, input. Okay. And then we're going to make, let's just call it buffered input, as in their example does. Okay, and then we need, so action, is that a message, or where's that action type come from? So this is opaque, right? But it takes a type. Buffers action presses for a specified number of frames, allowing players to press inputs slightly before they're valid. Oh, maybe we don't want that yet. I'm guessing this action is like translating an input into a message. Lots of gamepad stuff. We're not going to have that first. Okay, so they're saying, yeah, this is like, this is your action. So let's make, let's just go ahead and make an action type, and we're going to call it rotate camera. Keys, so forth. Okay, so they got mouse button. The mouse state, we're going to have to see what functions they provide for that. Okay. I guess we need to make a new, yeah. Okay, we'll say action. Okay. So init, we're going to need more here. Buffer input is going to be with buffer, let's say 5 frames. That's fine. Here. We're going to splat this for now because we're not going to update the input on tick. We're going to need to have something in the model for the rotation. So let's say camera, we'll say camera rotation is float. I think we'll have an angle, and we'll map that into a ring that determines the X and the Y position. Or not the X and the Y, the X and the Z position. And, yep. Okay, so that's gonna be our initial model. Okay. So I think we want to let's see if there's an example up here. Do we need bindings? New bindings. Possibly. We're definitely going to have a state in here, which is like is rotating, and this is not how we'll want to do it long term, but is rotating is false. You probably want like interaction states. It's more like a state machine and less like just a random Boolean field in your model. But I think that for right now, we're just trying to get something where we click and drag and the rotation of the camera changes. And then we can... It's not clear to me where you put these bindings. That's the problem. So new bindings, configuration. Does that need to be part of your model? This takes the input state, which comes from context.input. Okay, I don't think we need to create that explicitly. New bindings, input bindings, action. Let's not bother with bindings yet. I think that let's just say you're either on or you're off. And what we can do in our update okay. So yeah, okay. So let's try this. what we want to do is get feed this mouse delta, the x-axis of the mouse delta, into if the button is pressed. So let's do camera rotation. Okay, and we're gonna do is left button pressed. Input is left button pressed. And maybe we don't need this is rotating. We just need to know whether the mouse button is up or down, right? I thought we were going to have to do something where you press and then you enter the state and now you can rotate. But if we're just checking it every frame, I guess that makes sense. Okay, so if it's not rotated, then we just use model.camera rotation. Okay, if it is rotated, or if we are rotating, so if the left button is pressed, then what we want to do is we'll x delta. We're going to say input.mouse delta. Context.input. And then let's do, remember the mouse is going to be pixels. In here, let's go ahead and put camera rotation in here. Okay. So we want like half the screen, perhaps, to be a full rotation, or half a rotation. What else do we have in this context thing? Is it here? Yeah, context. Canvas width and height. Okay, so we can divide the x delta by the canvas width over 2. So that's going to be a float. Okay. So let's, and then multiply that by pi. Okay, so we'll say this is going to be x delta. We're going to multiply that by maths.pi. Okay, and then we're going to multiply that by, or we're going to divide that by context dot canvas width divided by, and that needs to be divided by 2 as well. I mean, we can start with this. But what we want to do is use the existing rotation. Okay, so we need to make sure that we associate these things correctly. That should work. Expected for arguments got 3. Oh, we don't need is rotating. Updates all fields. Okay. Okay, this should be enough to get a sum rotation, right? So let's see what we've got. Now the thing is, this is not going to actually rotate our camera because we haven't done the view. So we're gonna say we're gonna compute the camera position, right? And essentially we want to rotate it around. I think we want to keep the Z the same. So we're gonna not the Z. We're gonna keep the Y the same. We're gonna stay at like a certain height and go around the circle. So if we're using a radius of 10, we want to start at Z is 10. So let's just do this piece by piece. So we're going to say model dot camera rotation. This is going to be the angle. So this is going to be maths dot. So if it's at 0, we want to use cosine for this one. 10. And we'll use camera x is maths dot sine. Okay, so as the okay, so let's see if this works. Where are we? Camera. Okay, so what we want to do is transform at position, and then we're going to use here camera x and camera z. Okay. Okay, so we are up. Hey, look at that. We have camera movement. That was pretty straightforward. Oh, and hey, look at that lighting change from the directional light. So this is feeling a lot more like interesting and useful in that we can we did a very simple input operation, right? And again, I think that most of the work of update is going to happen in tick unless we're dealing with side effects from like an async operation, probably, right? And I'm actually surprised that this math here worked pretty well. No, like the x is in screen coordinates, right? The x delta. And then the, you know, so we can divide it by the canvas width. I was actually expecting it to rotate a lot faster than it does. We could potentially do we could multiply this by 2 or divide the canvas width by 2. Let's see what happens if we do this. Okay. There it's rotating quite a bit faster. That feels better. Maybe something in between would be good so you don't get dizzy. Magic numbers all over the place. This is games programming. Okay, so that's great. That's great. We got some easy camera movement. I don't want to go into why because that's going to get more complicated. That's then basically saying we're adjusting the sphere, and maybe we could do that. This rotation, we almost, what we need at that point is a unit vector. Yeah. I don't know if that is a useful thing to do right now. Note if we go up and down. If I let off the mouse, it doesn't move. We press the mouse, left mouse button. We're scrolling around. but only looking at it side to side. Okay, yeah, this isn't. I must say this is probably the fastest I've gotten to an interactive visualization in anything. So I'm quite impressed. Um, let's dig a little deeper into the docs here, and I think we can learn some more. Okay, so we could have a physics world if we enable physics. I don't think we need that yet, but we might want that in a future project. Spatial. Okay, so this is about spatial queries, probably finding colliders and picking, if I had to guess. Maybe not picking. Okay, so you can do message passing between Tiramisu and Lustre UI overlays. So we could do send things to Lustre, send things to Tiramisu. Okay. Let's have a more look at the stuff here. Dimensions. Okay. Okay, so the init function could return a physics world. That's what that option none is on the end. And the update also would return new physics. So they're saying you can do your physics computation, and that's passed separately from your game state. That's interesting. So maybe there's something where you would extract information from the physics world into your game state. I don't know. Okay. Okay, so state machines. All right, for animations, for example. Okay. So you can create state machines by adding different states with different animations. Okay. What I would love is, let's look at assets. Like what sorts of things you can load. You can load GLTF. All right, let's have some fun. Let's have some fun. Let's load a GLTF. Let's get one. I think I would love to see an example on this, but maybe we can just figure it out. Get model. So it's not clear to me. Okay, I guess you would do this in an init, create an asset cache. Yep, let's go to kenny.nl. I was actually going to download one of these a while back to just have locally. I don't know if you guys have seen. I'm kind of a fan of pirate stuff. Maybe we just get the pirate game set. This looks pretty fun. And what we could do is like, we'll want to browse it. What does this do? And maybe we can put one of these things into our visualization. Continue without donating. I will donate at some point because you are awesome. Okay, let's show in Finder. And I'm going to off screen move this into our project. Okay, so one thing that's not clear to me is where we should be putting this. Let's see if there's any guidance there. Okay. Now this returns a promise, so we'll have to put this in an effect. Can be used in C nodes or cloned for multiple instances. Okay. So I'm guessing this would be something in a scene. Get the scene object from a cached GLTF module. So when you call load GLTF, it doesn't put it in a cache. Okay, we're not concerned with animations right now, because I don't think that these things have any animations in them. All right, well, I'm just going to make a new directory over here. Sorry, you all can't see it. And copy that in. Let's see, we'll call it assets. And then we will move that into place. And then let's copy the Kenny Pirate Kit into there. Okay. Did that actually work? No, it got here. There we go. Okay. The thing is, since this runs basically under Lustre DevTools, there's possibly an interaction with the priv directory. No, I added this. Let's see what Lustre put in here. Okay, no. Build. Okay, so it's putting build dev. Yeah. Tiramisu demo. So this is the output of our of the compilation. Again, very, very straightforward JavaScript. Okay. We don't need to look at that, the rest of that. That's fine. Target JavaScript, Tiramisu. Okay, so it actually brought in 3JS in here. Interesting. Into our node modules. Okay, so if I had to guess, and we could get GLB or OBJ. Interesting. But OBJ has separate materials, and we probably want the materials in there, which the GLB would get us. What is this color map? Oh, okay. Those are the colors used in it. Okay. So there's some previews we could look at. And I think that for some of these, you know, it's like here are pieces that you can put together. I'm going to see one of the ships. Okay, so that's the large, medium, small has to do with the number of flags or something. Not scale. No, how small that is. Okay. So I wonder if we could say in here, let's do effect batch, and we'll go ahead and put the tick in there for now. But what I want to do is I don't really like it being in the model, but I'm sorry, in our app state. But maybe we could do, what is this asset type? Okay. So that would be, oh, you can have progress callbacks. That's interesting. Okay, so this comes from Gleam JavaScript. I think this effect is a tiramisu effect. Okay, so we probably need to look at how we can construct an effect from a promise. From promise. Okay, so okay, so we need something like this. Let's just make a function, and then that will be, let's say, fetch models. And this is going to be returning yeah, let's look at this. I think there's, you don't want race, we want a wait list. Okay, equivalent to promise.all. That's what I wanted. And then we'll do map. So map try, do we want that? So we could do with on this. Okay. So let's get import Gleam JavaScript promise. Gleam JavaScript promise slash, because we're going to need that for Okay, so this is going to be like a return. Let's just have it return effect.effect message. Honestly. And we'll do all of the goop inside this. Okay, so ultimately we want to come out with a promise. All right, well, let's make a message and say, assets loaded, data loaded, whatever. This is a message. Okay, so now we want more than that though, because we have what we're going to do here is use load GLTF, and this is going to return a promise result of GLTF data. And this is, that's not the right way to do it. Sorry, wrong language. Wrong language. There we go. And so in update, we need to do something with that. And model, let's say, I think the thing that we want to do is actually do this new cache business and load through the cache. No. Insert asset. Do we just do this? So load asset returns a promise. Right, and then we'll do promise.all, basically. Which will give us a loaded asset. And then we can put that. Yeah, so actually we don't want this. We want an asset cache. Yeah. The other option is that I mean, maybe I'm making this too hard. Maybe we have a fetch model which takes a URL string, right, and returns an effect. And then this is just asset loaded, a single asset. And we do, this is loaded asset, right? And then our little loop, our update can handle the loaded asset by inserting it into the cache. Yep. Okay. I think I'm starting to understand how to structure this now. Okay, so we're going to say model is going to have asset cache. Asset cache. Give me the cache. Okay. And we're gonna say asset cache. Let's rename that to assets. Assets. New cache. We may change that to new cache with size eventually. Okay, and then here we need to do asset loaded. And this is the loaded asset. And what we'll do is we will do the insert asset. So model. So we'll splat that and say assets is asset.insert asset. Oh, we need the URL. So it says insert manually. What's the way that we're supposed to be doing it? I know this loaded asset is opaque, but let's look under the covers. Okay, so it is GLTF data, but that doesn't have the original URL. So we're gonna have to hold on to that. Yeah, I think the main problem now is I just don't know. I don't know what. Oh, well. Or is what we do the batch load thingy. Interesting. And it has an asset cache in it. This signature here is interesting. I'm surprised this is not a function of load progress to effect. But okay. Okay. It is, in cases like this, I feel like it's always good to get a perspective on how it's implemented, especially when the docs are not answering the question. Okay, we will get there by the end of this stream, I promise. Okay, so maybe let's rethink this. So maybe what we do is we say, let's say assets loaded, and this would be an asset cache. And we'll use batch, right? So let me bring this back. What we're going to do is we're going to use load batch. Load batch simple. We're going to ignore and what we'll do is we'll fill this in with the different things that we want to load. Load batch simple has no progress thing. This is going to return a batch load result. So promise so what we want to do is promise map, and this is a batch load result, and we want this to map to so we want it to be a promise that returns a message. So we're gonna map this to assets loaded dlr.cache. Okay, and then we're going to go effect from promise. Okay, that's the main structure. Now we just need to fill in what we want to load here. So why don't we load model asset. Okay, and I want to get I don't know if this is even going to work, but we're going to try it. Kenny pirate kit. This is horrible. I mean, I understand why they do it this way. It's kind of like, hey, here's your introduction to this thing, but format. We're going to want to maybe simplify this directory structure. Okay, and which one do we want? We want pirate ship, or is it ship pirate? Let's do ship pirate large. Okay, I have no idea if this is going to work. But what we're going to do is throw this in here, fetch models, and then tick. And I think we need to update, yeah, so assets loaded, and this is the cache. We're just going to replace the cache. There's not really a merge thing, I don't think. Yeah, this, asset cache is opaque. There's no merge cache. Yep. Okay, so then I think what I want to do is pull this out into a constant. Say const pirate ship large string, and then that way we can use this elsewhere. Oh, right. So we need to do there's effect.none option.none. Okay. So here we need to splat the model again. Okay, so this was our update. I think that what we want to do is if we get model from our cache, let's see, both the 3D scene and any embedded animations. Okay, so maybe we just need the model scene. Okay, so this can return a result. So let's say pirate ship is a we want to get model scene out of there. From model.assets, right? Pirate ship large is the string. Okay. And if it's error, then we wanted to say it's an empty, because we'll make a group, and then if we do get the model data, so this is the obj, so we'll say object, then we're going to make a scene node and put it in there. So there's a question of, and I think we need to look at Tiramisu scene a bit more closely. Model 3D. Okay, so we give it an object 3D. And transform. Interestingly, there's animation playbacks. Okay, so we'll do a model 3D, and that turns it into a node. Okay, so we're going to do scene model 3D. It takes an ID, and that's going to be pirate ship. Okay. And then the object is going to be object. So we could just do it like that, I think. Transform is going to be transform at let's put this, say, like 5 units out. On the x-axis. Okay, so let's say 5.0 and 0 on the y and 0 on the z. And then let's like rotate y. So I want to rotate it slightly from the camera. So what am I saying there? I'm saying rotate Y. Sure, I know there's other arguments that we need. Okay, so then animation is option.none, and physics is option.none. So 5 to the right, and I think rotate around the y-axis, so I think we want negative rotation. So I just want to have it turned about 30 degrees from the camera. Okay. So we've created this, and let's make a little group down here, which is going to be scene.group. And so this will let us change the list of children and like potentially insert something that may or may not be present at all times. So ID is going to be pirate ship group. Transform is going to be transform.identity. And then children is going to be pirate ship. Oh, that's a constant, sorry. Okay, so I don't think that we have any other errors in here. Let's see what, oh, it's just like, yeah, it doesn't care. What's wrong there? Transitive and pending. Okay, so we need to, can you fix that? No, okay. We need to add that. I wonder if we need a restart. That's interesting. It's still complaining about that. Did we not update? Yeah, it's a direct dependency now. Okay. Restart. I don't need the logs. Restart all servers. Okay, well, it's not complaining about that anymore. Cool. All right, let's see if our thing is completely busted or not. Okay, so we don't have, let's see if there's anything in the console here. Failed to load resources, server responded to 404. Okay, so I think that it makes sense now to go ahead and make a priv directory. Priv. And I don't know if this is how you should do things. But let's say models. Let's call it models, and then it'll be easier. Okay, so let's just copy ship pirate large. Copy that. Paste it there. Okay. So let's do priv static models ship pirate large, and then okay, so it's getting 404 there. One thing that's not, remove that. Yeah. This is like in our other one, we would put things in priv static that we actually wanted to have exported, but I don't know if Tiramisu does the whole dance of Okay, at least our view function did not crash. But we did get $404 there. Yeah, it's not clear to me where it's serving out of. But technically, maybe it's serving out of build dev JavaScript, because it's serving that, right? Lustre Dev Tools. That's interesting. Let's just have it look at what Lustre Dev does. Let's go to okay, starts a development server. Source and assets, but it doesn't have any clue that we need to copy that. Okay. Okay, it tries to build. Okay, if it has node modules, yada yada. Okay, it runs bun build. Okay, there's no tailwind entry. We're not doing that yet. Okay, start a watcher. Server start. Well, let's go to this. What does this do? Okay, so it looks in the priv directory of Lustre Dev Tools. Okay. There's a load STS. Oh, okay. Yeah, let's have a look at that. Thank you for calling that out. That'll save me some time. They link from here. No. But we could look in the repo potentially. Yeah. Repository. Okay. Examples. Say 11 STL loader. Well, here's asset loading. Let's read this, and then we'll go to the STL loader if that makes sense. Okay, so in their init, so they're constructed a load state. Okay, so they make some assets to load. They make a load effect from promise. Promise, yeah, this is basically what we were doing. Load batch. Okay. It's an update load progress. Okay. All right, and at the end it says assets loaded result. Okay, and result is going to be that batch. So, okay. The thing that's interesting is, What is it trying to load? So let's look at where this metal color.png is in assets. Okay, so it's just straight there in assets, which to me says that you know, we did all this business, but maybe what we need to do is not make this priv static directory. Can delete the whole thing, thanks. It would be to copy our ship pirate large and put it let's just do it here on the fact that it has spaces in there bugs me. Okay, so we copied it directly into there. We can maybe move the, let's make a new folder, raw assets. I'm not going to commit this one. I may not even commit anything today, but then the ones that we're using we copy into there. Okay. Yeah, I thought I was with the priv directory, because that's like usually what you do when you have a web server, but it looks like Luster kind of wants and let's just restart. It kind of wants them in specific places. Oh, look at that! We got a pirate ship. It's pretty big. Okay, so it really just was about, okay, so it didn't find the color map. So I think what is that looking for? Textures color map. So we need to make sure that, because these don't have ping textures. They're just like an index into a texture file. So we need to copy that over. We'll copy that into here. And reload that. Okay, so now we've got color map. Look at that. Look at that beautiful pirate ship. He's pretty big. There's some banding going on there that's kind of interesting. I think that could be intentional. Let's look at that textures color map picture. Okay, so there's this sort of thing going on. Maybe that's just to make it look like it's got some depth to it. Although there's also the color banding on the other things. So up close and personal on a pirate ship. I don't think it was meant to be this big. Thank you for that pointer, Martin. That was great. So that was fairly easy to resolve. Looking at that example. Okay, so now I think I need to scale this down, right? So that rotation is fine. Let's do transform with scale. Splat. I'm just going to scale it down. Let's splat it down to 0.5. Okay, that's much more reasonable. We can see the whole thing. And it doesn't look like we're, up in its business completely when we rotate around. Okay, now one thing that's kind of tripping me out is the plane is below. And I think that we can, let's clear out our sphere scale. That was just good to show activity over time, but now our big thing is the rotation. And we will not have the sphere scale. We need a C for that boat. Yes, we do. We're not really making a game right now. I'm just trying to learn how to manipulate things. But where's that sphere? Okay, we don't need to change the scale anymore because that's not part of the model. Yeah, build error. It's wrong. Where's the error? Oh, right. So, but I didn't remove it from here. Okay. Okay. So now the sphere's not flying around. We need an ocean for that boat. What have we got in over here in the Kenny? So previews. There's no. I don't think that there's any ocean thing. What might be interesting is to use our plane that we have down here. And we could I wonder if we could do a vertex shader on it and throw some noise at that. And that way we could change here. Let's take this color. That blue color for the sphere. And let's throw it on the plane. So I think what we're going to do is we're going to get rid of the sphere geometry. Let's make this plane bigger. We need it bigger. And we're going to get rid of the ground material because we're going to give the ground. So why don't we rename this to water material, and we'll get rid of the ground material, and let's rename this to water geometry. Okay, we're getting rid of the sphere by sphere, and ground water material. And we'll call this water. And okay, so here we can bring this up to 0, or maybe just like slightly below 0. This Euler rotation is interesting around X. Okay. Hey, we got some ocean. Oh, and look at that. The ocean has some shine on it. We're going to need to do some more with that. But so I think what would be interesting is look at what we can do with a shader, like a vertex shader, because I think that this is just going to be 2 triangles, right? So we would only be perturbing the vertexes there. All right, let's see what Tiramisu has in terms of geometry showcase. We can look at the docs. Okay, so there's level detail effects showcase. Okay, so those are when they say effect, that's not like visual effect, that's effectful programming. Yeah. Okay. Scene hierarchy. Let's look at this example. Great examples in here. Okay, so we could start to do our own IDs. That would be pretty useful. Okay, so it looks like what they're doing is they're making a planet system with a couple planets and moons, sun, points, etc. Okay, and they're doing pretty similar to what we did, which is like computer rotation. Note the division by 1,000 for milliseconds to seconds. Okay, so their camera. Right, this pretty typical stuff. I don't know why they piped that. Why they just do camera with without the underscore. That's kind of weird. Could the plane be sine waved? Yeah, that's what I'm trying to think about. Like, because I would want to do something like a noise function potentially, or yeah, or have a geometry such that you have some points in the middle that can be, you know, offset sine wave or something like that. Okay, so they're doing a lot of stuff here. Oh, that's interesting. They return a single scene? Not a list of scene nodes. I guess that's okay. Okay. Let us go back to the documentation. So I'm pretty certain that this plane is not going to give us enough. Let's look at the implementation of this. I bet it's just a direct FFI call. No, okay. Plane geometry. So, right, that's not that hard. Okay, so create plane geometry. Yeah, okay. So this is the FFI bit. And this 3 geometry is opaque, I'm betting. So if we want something else, we're going to have to get into poking at 3.js. I guess we could also do instancing. The thing that I want to have is deformation of the original geometry without doing something in here, right? So I want to get a vertex shader, not a fragment shader, and have the vertex shader have some inputs, like for each vertex attach something, which we can compute, and have that be, like you said, Martin, like a sine wave in there somewhere, right? Or I don't know, Perlin noise or something like that. So there's probably a bit of a spatial partitioning. There's probably a bit of a thing here where we might be hamstrung. Okay. So let's look at their FFI and see if there's anything that we can do in here that'll be interesting. Okay, maybe we can find the like create plane geometry. Yeah. Okay, so this is 3.js plane geometry. That makes sense. It's just kind of a straight shim. Well, let's look up 3.js and see what we can do. See what we can learn from that. Materials, textures. Post-processing. Okay, no, that's 2D image. Okay, so here, there's the descriptions of the different kinds of materials. Oops. Mesh depth of material renders the depth of each pixel, where pixels at negative near of the camera are 0 and negative far are 1. Okay. Mesh normal material will show the normals of the geometry. Okay. That doesn't quite say. Custom buffer geometry? Subject lighting buffer attributes, right? So we would want to create an array of buffer attributes, or a buffer attribute, right? And name it like phase or something, or wave, or I don't know. All right, we're going to wrap up pretty soon. Okay, so they're talking about constructing a cube with normals and UVs. Okay, so then there's this buffer geometry thing. Do we have anything like that in Tiramisu? I don't think we do. Here. Let's go back to the docs. Anyway, this has been great so far. Oh, so there's custom geometry. Ah, okay. So, So the question becomes, in my mind, can we, maybe what we need to do is, the problem is this is opaque, right? Do we need to have some kind of custom geometry. Now, if this is an alias for the 3.js buffer geometry, then we could potentially create our own FFI that creates some of this stuff, right? If that's what this is. Probably is the case. So anyway, that's something we can do for next time. The thing is, what we want to probably do is think about how we might generate those attributes on each frame. And then maybe what we need, rather than a simple plane, which is two I'm sorry, which would be two different triangles, we need like a flat mesh, which have a bunch of different triangles. So like n by m or something. We can pick the number of vertices that makes sense. And then we can potentially set the attribute on that geometry with something like this. And see if we can tweak it. Maybe this is too much for the first pass, but it would be great to be able to do that sort of thing. And you know, they're doing some pretty impressive stuff here. The thing that I was thinking was that we would need to get down into the shader, but it's not clear to me how to do any of that with Tiramisu yet. Maybe there's something we need to contribute back. Maybe they are looking for something particular about, like, something that needs to go into the communications with 3.js that we can do outside of Tiramisu. I'm not sure yet. But this is probably a good place to stop. Thanks for hanging out, and we'll learn some more next week.